Hi everyone, this video is about the power of optimization in order to personalize your trading strategies for a financial instrument you are trading. And we will show how we use optimization in order to go from a win rate of or return of minus 5% to a return of close to 1%. And we achieve this about 6% gain in returns through optimization. If you look up the internet on SMA trading strategies, you will be recommended to use a moving averages of 5, 8, and 13 day or 13 bar simple moving averages in order to construct your strategies. In this video, we want to ask if this is the right number of bars you should consider for your trading strategy. And the message that I want to give with this video is that these parameters which are suggested on the internet may not work for your trading instrument. It may or may not work for your trading instrument. And if it does not work for your trading instrument, we want to go through optimization to understand how to get the best parameters for your strategy and the instrument that you are trading. So let's start with the strategy itself. The strategy here is the moving average crossover strategy. The strategy is pretty simple. The idea is that we have two moving averages. One is the fast moving average, which is this jagged red line here that you can see. This is the fast moving average. And this could be the 5-day, let's say the 5-day or the 5-bar moving average. And then there is the green line here, which is smoother, and this is the slow moving average, which takes a larger number of bars into account. So this is the slow moving average. So the idea is we take a trade when the fast moving average crosses the slow moving average. Always remember the nuance that this is the candle where the fast moving average is crossing the slow moving average, which means that you open the limit order on the open value of the next candle, which is somewhere here. So this is in simply the trading strategy. So we look at Bitcoin data at 5-minute intervals, which is sort of a standard data set we use throughout our videos. And again, this will be personalized for your own instrument. So for this particular data set, at first we want to the 5 and the 10, the 5, 8, and the 13 SMA doesn't help us with the illustration because it's too close to the candles itself. So we use a different sort of numbers, 20 and 100, just to illustrate what happens when we apply the moving average crossover strategy. So in Python, in order to apply the moving average crossover strategy, you want to do two things. You want to calculate the first fast and the slow SMA, which is you specify the values of the fast and the slow SMA, and then you call this rolling function, which calculates sort of all kinds of rolling calculations in pandas, and then you call its mean. And then you want to do two things. As I suggested previously, you want to know what happened in this candle, which is the fast moving average is larger than the slow moving average in this particular candle. And then we want to see if the fast moving average was less or equal to the slow moving average in the last candle, for which we use this shift function. So in the previous candle, the fast moving average was smaller than the slow moving average, and in this candle the fast moving average is larger than the slow moving average. That is the condition for entering a trade for us, and we define this column called crossover, where you can see that this happening. And again, as I said, you can only enter the trade in the next candle, which is why we shift the candle values by 1, so that we're only taking into account information from the previous candle. At this point, I should also mention that I have separately made videos about the simple moving average crossover strategy itself before, which I will link both in the video and the description below. And secondly, I also have a video about optimization procedures of trading strategies, which I will link in the description below and the video here. So these videos will sort of help you understand the code even better. But let's come back to the code and see what happens in this illustration. Again, these numbers are not that important here, but just the illustration is important just to show you where we take the trades here. As you can see here, This is the place where the fast moving average sort of, we have this blue line, which is the fast moving average. It goes above the slow moving average. Let me illustrate this in the plot, a more zoomed in plot. This is a zoomed in version of the plot, and you can see here where the fast moving average, which is the blue line, just crosses over the slow moving average, and this is where we enter a trade. Unfortunately, this trade, we lose this trade because we hit our stop loss and we exit the trade here. And then we sort of take similar trades. We lose another trade here, but then we win the third trade, and then we go on to win the fourth trade, and so on. But again, these parameters are completely for illustration purposes, and we do not use that for helping us understand our the performance of our strategy. In order to understand the performance of a strategy, we use the default settings. As I was saying, if you go to Investopedia and ask, what are the strong moving averages combination for daily trading? These are the numbers you would get, 5, 8, and 13. And many of you will plug this into your software and use this for trading. But what I want to tell you today, and this is the main message that you want to take away from this video, is that maybe you should not do that. You should sort of test these numbers in Python for your own financial instrument and for the regime that you are trading in. Sometimes that you are trading in a more volatile regime, sometimes in a calmer regime, which will change your parameters. So we look at a data frame of about 5,000 data points, where we use the recommended parameters, the fast SMA being 5 and the slow SMA being 13, and we go through the exact same calculation. We calculate this column called the crossover, and then we take a enter a trade when we have a when the crossover is 1. And again, I have another video on how to sort of backtest these strategies and the backtesting library that I built. It will be easier for you to sort of follow if you go through that video. But just very briefly, in our backtesting library, we define a strategy by saying what is the entry point of a trade. In this case, we say if the crossover is true, then the entry point is we decide that as the entry point. So we define a variable called the crossover, which is true when the crossover value for that particular row in the data frame is 1. And if the crossover is true and we have enough money to buy the instrument, we buy 1 Bitcoin. And the way that we use about 80,000 of cash, so we could buy only 1 Bitcoin at a time. So let's go back to where we were. So we use the default parameters, and let's see what happened here. So our buy and hold return for this period of 5,000 sort of candles is about minus 5.85%, and our return using this SMA strategy is only minus 5.6%, barely above the buy and hold return. And this is why I said that the default parameters may not be the right parameters for your use case. So what do we do next? We optimize the strategy. We define this optimization function where we take all the possible values that we can optimize in our strategy, all the parameters that is possible to optimize as arguments. And then these are the fast and the slow SMA values and the profit and the stop loss percentage of our trades. And we do this hacky thing to get a constrained optimization problem. So in this case, it is not possible for us to for the slow SMA value to be larger than the fast SMA value. So we return minus infinity if that happens in order to get a constrained optimization. That's our hacky way to get a constrained optimization. So we consider a separate data set. We consider the first 2,000 points. Remember that we tested the strategy on a separate data set of from the 2,500 index to the 5,000 more points from there. So we use a separate data set for doing the optimization so that we are not overfitting. And the idea is to calculate the final percentage return for each of these arguments here. And here we show an example. Now we give the parameters that we want to optimize over. So we use these different stop profit and stop loss percentages. For SMA values, we use the recommended SMA values, but we also use some other SMA values. And just for your consideration, remember that these fast SMA value numbers that we are testing out are generally lower in range than the slow SMA value numbers, because we only get a valid result when the slow SMA is larger, has a larger value. So we don't want to get into too many of these invalid cases and waste our computational resources. So we do a random optimization. We run 100 of these random sort of points inside this huge grid, and then we calculate the best parameters. Interestingly, the best parameters are not what are suggested by Investopedia. It is not the 5, 8, and the 13-day moving averages that is suggested. In fact, it suggests to us to use a fast moving average of 13 and a slow moving average of 20 days. It also suggests to put a smaller stop loss, which means that we exit our losing trades early and we carry our winning trades sort of further in order to make larger profit. And then what we do is simply say that we are going to plug in these values into the best parameters to our algorithm. And then we again calculate the crossover, and with a cash of 80,000, we execute this strategy. As you can see here, our win rate is now positive. Even the buy and hold return was minus 5.85% of the Bitcoin, when general was going down during this time. Our optimized SMA crossover, which was optimized on a very different data set, so it's not overfitting, is giving us a positive return about 6% above the return of the buy and hold, and also about 6% above the return of our non-optimized strategy, which followed the Investopedia recommendations. So hope I convinced you that you should use Python in order to backtest the parameters of your strategies before applying the strategies in any kind of trading situations. And again, the description to the notebook is in the download link, so that you can run these optimizers for your own strategies. And hope you are convinced about the power of optimization of trading strategies. Thank you. Please like and subscribe this video if you find such Python executions of trading strategies useful.